Okay, so first question is, I have a question about pursuing tenure. Did you have to start over the full 5-year evaluation period when you switched to San Diego? And the follow-up question is, what usually happens to those who do not get tenure? Do they look for other assistant professorship positions? And this is from a user on YouTube, Marsag. So my tenure clock reset. So in theory, I have all, like you mentioned, the full 5 years. So in theory, I just finished my first year. So I can treat this as an entire full tenure clock. That usually happens if you move pretty early. So I switched schools after 2 years. So after 2 years, I switched schools. So I have the full time. But I can actually try to go up for tenure earlier because in theory, the work that I did at the University of Rochester in the 2 years prior, counts as well. So, I could say that I finished 3 years total on the tenure track. But, my official appointment is that I started last year at UC San Diego, and I have the full 5 years. And for the other question about not getting tenure, I think a lot of people, especially in kind of science and engineering fields, the most common case people do is that they go into an industry research job, like an R&D, or even an engineering job in industry. That's the most common case because by that time you have built up like 5 years or 6 years of like a pretty good body of research, and you're pretty well poised to be in a mid-level research or research leadership position in industry. So first of all, not many people I know have not gotten tenure. I mean, that's a double negative. Most people, if you're doing your job properly and progressing properly, hopefully things should be okay. But most people go into an industry position. There are rarely cases where people go look for another assistant professorship position, but I think honestly, like by that point, you're so discouraged that you probably don't want to do that again. The only exception is there are some schools that are notoriously hard to get tenure in. So if you're at a school like MIT or Harvard, or other of these top schools, these people who are professors are all really amazing. And some of them just end up not getting tenure for one reason or another. Usually another school will hire you with tenure. So in that case, you don't get tenure at Harvard, but you get a second academic job and you get a tenured job at another university. So that's what ends up happening to folks who don't make tenure, usually at these top schools, is that they're still obviously, way better than most people in the field. So they're able to get a tenured position afterwards. Hi there, what advice would you give to a computer science major student that you wish you were given when you started computer science? So I assume this is for an undergraduate major. For an undergraduate computer science major, I mean, I think the big advice is to really kind of understand, I guess, what benefits there are in being in a school environment and what you can't get when you're outside of school, right? Because if you're in a 4-year university, for example, you only have those 4 years to be in school, but you have perhaps, decades or more out of school when you're working. So one example of this is that like computer science is a strange field because like a lot of the practical stuff you learn about like web programming or new libraries or, DevOps or cloud computing and stuff, all of that changes really fast and they're very industry specific, right? You're working in industry, you might be using MATLAB, you might be using, Windows, some Windows version, you might be using some proprietary OS, you might be using Amazon's cloud service, Microsoft's cloud service, Google's cloud service, some JavaScript library, some Ruby library, something different in your work. And you can't possibly learn all that in school. And what school is good for is learning these fundamentals that hopefully won't change that much with time. So I think that one, perhaps, time when people get in trouble is that they're really obsessed with learning a lot of specific technologies while they're in school because they want to be marketable in the job market, which is reasonable. Of course, you got to do some of that. But then when they get on the job market, they realize that you'll always have to learn new technologies as new technologies come up. And then you kind of didn't take advantage of what school is really good for, which is learning the fundamentals, being in class environments, being able to work on research projects or other sorts of non-commercial projects with friends or with professors and stuff. These sorts of things of building up fundamentals and also, socializing, attending these, hackathons or other events, doing extracurricular stuff. All of those things are not necessarily computer science related, but I guess my my advice I would give to people is, really take advantage of those 4 years you have, and and you have the rest of your career to work in computer science or in software development and stuff, and you'll always have to learn new skills. But once you're, I hear from a lot of colleagues and friends, and is that once you're outside of college, it's just so hard to get some of these experiences, like being a dorm room late at night and making projects with friends, or hanging out with people, or doing these extracurricular activities. These things are very hard to do once you're in a job. Is there a way, I am doing my PhD at a top 30 school in ECE, electrical and computer engineering, I'm assuming. Is there a chance to join to get a professorship at a higher ranked school? So this is a question of like, I am at, usually in some major, there are some rankings, right? I mean, there are lots of rankings, but in general, right, people know the top 10 schools in your field in whatever area. And then there's like other schools that are ranked 11 to 20 and to 30 and 40 and stuff. And my feeling on this is that, beyond the top 5 or 10 schools, the exact numerical rankings don't matter as much, right? Like, it doesn't really matter if your school is ranked 15 versus 21, right? Like, it's just like that number doesn't really matter at all. The question is if really is a real legitimate one of, if you're at a certain level of school, what are the doing your PhD in a field, what are the chances for you to get a assistant professor, a tenure track position at a higher ranking institution? One of my colleagues, Aaron Clauset at University of Colorado Boulder, he got a lot of press attention for this paper he wrote studying hiring in academic job markets. Exactly this question. And basically what they did is they took data, they took where people went to PhD, their ranking in their school, and then where they got hired as assistant professors. I think they did it the other way around also. And basically it kind of backs up intuition, right? That usually you get your PhD at a certain institution and you get a job as a professor at an equivalent or quote unquote lower ranked institution. And it's actually very, very hard to get a professorship at a higher ranked institution because, one of the reasons is because the graduates of those higher ranked institutions are really competitive for those jobs, and they're trickling over into other universities as well. I mean, I think this is just a fact about the scarcity of the job market, right? So, if you just do the math, that already at your same level of institution, right? Let's say you're at, for lack of general specificness, like a ranked 25 school, whatever that means, right? I mean, I don't like rankings because it's seems arbitrary, but let's say you're at a ranked 25 school. Other schools that are around rank 25, they only have one assistant professor position in your field for every 10 graduates, right? And that's a school at your own ranking. So you're still at like a 1 job to 10 graduates ratio at your own ranking. Now imagine going up to a school in a higher ranking, the odds are going to be even less. So unfortunately, the numbers just work out in that way. So I think that is a challenge. What is your opinion on P versus NP? Wow. Well, I think I don't have a quick answer to that. Well, unfortunately, I don't have any better ideas on P versus NP than anybody else who is just watching YouTube, because I'm not a theory person, right? So I'm not a theoretical computer scientist. I took some theory classes in college and in grad school just to pass my exams. I did this computability class and stuff. So yeah, I have absolutely no idea about that. I think folks such as Scott Aronson, who's a professor. Oh, Scott Aronson is now at UT Austin, I think. So Scott Aronson, Aaronson, he writes a really popular blog on theoretical computer science, and I think he's tackled this quite a bit. And then he often kind of writes about people sending in supposed proofs of P equals NP or not equals NP, and then and what he does about that. Caffeinated bloodstream. I like the username right there. I don't endorse drug use on and off the air, but caffeine might be okay. Even though it's way more addictive than a lot of other drugs. Hi, is it technically possible for humanity to have already created an AI that simply chooses not to reveal itself? One lurking in the shadows and on random hard drives across the world. That's a really interesting question as well. It is, I think it is possible. I wouldn't know about it, obviously, but one analogy I have here, So this question was about, is it possible that we've actually created an AI that's just like awesome, but it's choosing to hide and not reveal itself now because it's kind of like lurking in people's computers and, waiting for a day where it reveals itself. Yeah, there's two analogies here that I like. All right, let me get a note. I'll queue up. I'm very bad at multitasking. This is an interesting question. So one analogy here is for viruses and worms, right? So it's very possible people have, some of these really famous pieces of malware, viruses and worms, go and infect a ton of computers, and they lie dormant, just like just like biological viruses do, and they're waiting until a certain day, right? They're waiting until like, some important day, and then they get a trigger and they all activate and they like take down a really popular website, right? They take down, a bank website or a government website because it's a concerted cyber attack. So it's very possible that those things definitely exist. The other analogy I have is that like the government routinely does secret R&D research that is well ahead of its time, right? It's classified, it's highly secret. That's well ahead of the technology available to civilians and general public. So thinking about the history of computational technology and other technologies, the government knew about this stuff and they were developing this stuff in secret for maybe wartime purposes many decades ago. And then they slowly declassified it, and then those people went out into industry and academia to distribute it. So like, obviously I have no idea, but it's very possible that advanced governments have developed some really advanced forms of AI that they're maybe testing internally, or they might have even like installed it on many of our computers and are just monitoring us. I mean, there's definitely cases of cyber warfare of governments installing malware on people's machines to snoop on internet activity and those things. So that's, it depends on what you call AI, right? I mean, I think that, the movie version of AI is like your computer is going to morph into some like sentient robot that's going to kill you in your sleep. That may be kind of farther off, but AI is defined as some computer program that can learn from your activities and that can predict things about the future and that can affect economic markets and global markets and everything. I think that's very possible. I mean, if you think about what people are doing already with AI now, I think it's really possible. Do you regret the name Python Tutor, since a lot more languages supported now? That's a really good question. So for those of you who don't know, I run a popular website called pythontutor.com. Python as a language, pythontutor.com. Funny thing was that was originally called Online Python Tutor when I first made it. This is like 8 years ago now. And then I shortened it to Python Tutor because it was a shorter domain. I actually had to buy the domain. I think it was like a few $100s. I had to actually buy the domain. Online Python Tutor is free, but it was like a long name. So it's kind of like how Facebook started as the Facebook, and then they shortened it to Facebook. The funny thing about that name, Online Python Tutor, Python Tutor, was I originally meant for that site to be a site that gave you tutorials, right? Hence the name Tutor. I originally meant for the site to have practice exercises and debugging tools and just kind of be like a simple thing, like a simple Codecademy or Khan Academy. This was made before MOOCs, before these open online courses. So like there weren't many of these interactive activities back then where you could write code. This was like 8 years ago, right? There weren't many things where you can write code and and like step through it and debug and solve exercises. So I wanted it to be a tutoring system. But in fact, many years later, like you mentioned, it's neither about Python nor about tutoring, right? So neither part of the name Python Tutor actually is true. It's not Python and it's not tutoring. So it's not Python because now it's actually many languages. It's a suite of languages, including Python, JavaScript, TypeScript, Ruby, Java, C, and C++. So it's a bunch of languages. And it's Frank. How's it going, Frank? Frank is in the chat. I'm going to pass it over to you, Frank. Frank muted himself. You can type in the chat also or just watch. So there's another chat going on in the YouTube stream, apparently. So I'm answering those questions. All right, to finish up that question, I have tried thinking about changing the name several times, but I never really got over the momentum because one, the name is already pretty popular. It's, comes up first on Google searches. And the other thing is that like, as a practical thing, I've already written a few research papers, gotten research grants, kind of, use this Python tutor platform to really launch my research career. And now like people in the research world just kind of know it as that. So when they cite papers and when they write about it, it's all just called Python tutor. So it is an unfortunate name at this point, but I think I'm sticking with it because like it's already been several years where people are writing papers about it, and like I am writing papers about it. People are citing it. One really successful example of a name switch is Project Jupyter, Jupyter. So that used to be called IPython, or the IPython. Well, IPython was where it started, which was an enhanced Python shell console. REPL, sorry, an enhanced Python REPL, and then they made an IPython notebook, which is a web-based, cell-based development environment, a literate programming environment for Python. And then they faced the same issue I did. They started expanding to several different languages and making a more generalizable platform where you can plug in any language and write code and visualize, do data visualizations and stuff. So then they renamed it Project Jupyter a few years ago. And renamings are always tough, but I think they've done a really good job. And now people basically know it as Jupyter. They have a big advantage over me in that I am one person and they have entire teams of people and marketing and a lot of, they are a lot bigger of a project. And I think that they're able to pull that off because, they have real professionals working on this and it's not just like one person. Okay. But yeah, in conclusion, the name will probably stick for a while because there's already a legacy with it. So this is about, I love your post, this article on academic high achievers turning 30. So for reference, that was an article I wrote. If you just look for academic high achievers turning 30, I think turning 30, like 30 years old. That was an article I wrote. Basically, I sent out a survey to a bunch of my friends. This is when we were all about to turn 30. This is like 4 years ago. And I just sent like a Google Forms survey, really simple survey. I had 2 questions on it. One question was, I forgot the wording. Compare when you're now 30 years old compared to when you were 20 years old. Comparing 30 and 20, what do you feel like you have more of now at age 30? And then what do you feel like you have less of now? And just go and list some things. So I did a big write-up about this. I got 160 responses, I think. I just sent it out like on Facebook and email and friends and stuff. And these are all just my friends and acquaintances. I found a bunch of stuff on that. You can read the article for more, but let's see. So the question was, can you elaborate more on your motivation on doing this research? And what were the most important things you've learned and perhaps applied to your own life? So the motivation was just for fun. It was a winter break project. It was kind of that was my first winter as a professor at the University of Rochester. And Rochester has pretty rough winters. So if people don't know about upstate New York, it's like super snowy and dark in the winter. It's almost, it's basically where Canada is. It's very far north. So I decided to try to do the survey as just a thing to do over winter break. And I think that turning 30, you start thinking about a lot of stuff. It is just a number, but we think in terms of decades because we have 10 fingers, I guess, and we're in the decimal system. So, 30 is kind of a milestone in people's lives. And many of my friends from college and graduate school, it has been 10 years since we were in college. So I thought it was a good time to reflect and send out that survey. And what I learned from it, I wrote about all of the stuff I learned. What I applied to my own life, I guess the thing to apply to my own life was that I think that at every age, it's important to take advantage of all of the quote unquote good things about that age that you have more of. And then when you age out of something and you move on to the next phase, don't look back and think, oh, I could have done more or whatever. I'm just going to take what I have at my age now and my experience level and run with it. And then when we're 35 or 40 or 45 or 50, I feel like at each age, more or less, people have certain sets of skills and also constraints, right? And to really run with that. For example, people at 30 usually have a harder time staying up all night partying or like pulling all-nighters than people at 20. So we just can't do that as much just because physically we can't stay up so late, as much energy. That's okay because we can do other things. And maybe that the lesson there is when you're young, you should take advantage of being able to eat pizza all day and have no consequences and stay up all night and just really take full advantage of that. Do you have advice for aspiring PhD computer science student to get research experience or to improve admissions chances if they're no longer in school? Okay, so this is a common question I get is if you want to go back to school to do a PhD, but you have been out in industry and you're not in school. What can you do? I think that's challenging. I mean, I think the one thing that I would say is, it's going to be really hard for you to get into a top program, because top programs are going to be filled with people that are highly competitive on the market. They're usually right out of school. They have very strong recommendation letters from researchers. So the first thing I would say is apply to a broad range of schools. Don't just say, oh, I want to go to like a top 10 school or whatever, because that's really hard since you're already in industry. The other thing is to really show that you have kind of good experience doing, this is computer science, right? It says PhD computer science, to show that you have really good experience doing software engineering and like building real software, making software work. Because, even though you may not have as direct research experience, what professors and labs value is someone who can actually build software well and quickly and understand and have the maturity to manage projects. So, when thinking about, looking at applications as someone right out of college, without much research experience, maybe they're doing okay in research, and someone, say maybe like yourself, who's been 5 years out of college, but has worked in a company doing software development and been shipping software and getting a good recommendation, people might actually want to pick the person from industry because they know that they're more mature because you're a bit older and you've actually worked for 5 years. So you kind of know how industry works. I have some students that I've worked with that came from industry, and they've been good because they've been very good at building software. And I think that's a skill that is really necessary. So I would really play that up. But I think it is going to be hard to get into a top program because those students are usually coming from places where they have a lot of fresh research experience. Okay, will the hype of AI have an effect on the academic, I assume the faculty or job market, for other fields such as systems? I guess this is a very computer science question of, now AI is really hot. A lot of people are hiring deep learning, AI, big data. What happens to the faculty jobs in other fields like computer systems or theory or human-computer interaction? That's a hard question to answer. I mean, I think that my positive answer is that the hype of AI means that more people are majoring in computer science. And because more people are majoring in computer science departments want to grow. And because departments want to grow, they have more room to hire faculty. It is true that it will probably be easier if you're in AI or in a hot field, just like any time. But I feel like, so there may be schools that will only have an AI or machine learning position because they really want to expand in machine learning AI. But I think that, again, given you're applying to enough schools, and you should first apply to a lot of schools because it's hard to get a job at any one school. If you're applying to enough schools and schools are in a growth mindset, a growth period, which computer science departments still are, fortunately, there are going to be more general positions open. Of course, it's still competitive, but it's better than, say, not having an AI hype and the economy being in a recession and nobody hiring in anything, right? So I think that the positive view is that the AI hype means that computer science is more popular, which means that more students major in it, which means that departments have more money to grow, which means they can hire faculty. So I think it's hopefully good for everyone. Do you still use CDE on a daily basis? So CDE is a tool that I made in grad school, CDE, which lets you package up software so you can run it on other machines. So people who know about Docker, like the Docker tool chain, CDE is kind of a precursor to something like Docker that solves a very similar problem of you have different machines with different configurations, and you want to, oh, someone joined the video call. Okay, so you can chat in the chat window if you want to ask questions. I'm just answering questions from the YouTube chat. Yeah, so CDE is kind of a precursor to Docker, long time ago. It's funny enough, I haven't used CDE for like 7 years, ever since like really making it. I have not touched the code at all. I heard that it still compiles, or the binary files that I have on the website still work, but I literally have not maintained it at all. I mean, I've totally moved on. It's like 7 years ago. I mean, it was 7 years ago, but I think the code is pretty portable, and people sometimes email me still about it. If they have a bug report, I just say, I'm sorry that you're out of luck, because I have not looked at that code for 7 years. And I would just say, just use something like Docker. I mean, Docker is the production grade version of those ideas, and they have a company backing up. They have a giant community. So use Docker. CDE is this prototype made by one person 7 years ago. Do you have any specific suggestions for people to become comfortable with academic writing, in particular, people for whom English is not the first language? That's a really good question. So how do you get comfortable with writing academic papers or writing any papers, I guess, when you're not an native English speaker writer? I think that's really hard. I would say one way is to just read a lot of papers. And by reading papers, I don't mean just like reading papers necessarily for research, but reading papers for looking at their style and how they present things. One example is, yeah, actually, he wrote a follow-up. The obvious answer is to write more. Are there any other habits one can develop, tools, books, exercises? I would say reading, and reading papers with an eye on like how the things are structured. So like, for example, if you can print out 10 papers in your field and you want to look at the results section, and usually all the results sections are written up similar way, right? If you're in a certain field, people are going to run a certain set of experiments and they're going to present a certain set of data, and they're going to write, here's our experimental setup, here's our, whatever, here's our results, here's our findings, here's our limitations and caveats. I think if you read a bunch of those, you can start seeing the kind of language people use and learning from patterns from that. And then there's just general like English nonfiction writing books. I don't know of any really good ones off the top of my head for non-native speakers. I think that would be a great question to look into, actually, of, is there a kind of exercise or workbook for people who are not native speakers? There are forums online, right? Like people Google for forums like, what is the right usage of this word? Should I say toward this or towards this or to this? Or, there are some of these idioms that people look up. I would say, another way to do it is to just get a lab mate. If you're a student, get one of your lab mates or colleagues who is a native English speaker to look over your writing. I think that's the best way, actually. And, you may want to get your professor or PI to look over it, but usually they're really busy with a ton of projects. They may not have time to look over your writing in great detail and fix kind of the non-native English things. So I think friends and lab mates are great people for that, because they're your peers. They usually have a bit more time. They might want to help you out and stuff. So, and who knows, you might be able to teach them your native language as well. So that, I think that could be fun. So I think getting other people to look over your writing, like really honestly, but someone you can trust. What in your opinion are some research areas in computer science on the verge of exciting breakthroughs, even better if not hype topic like machine learning? That's a really good question. I am obviously super biased because I work in human-computer interaction and in areas that involve people in computing. And I think, I don't know about a breakthrough, but I think that HCI, or human-computer interaction, it's been around for a long time, but I think that it is poised to be in the mainstream in computer science in the coming decade. Not necessarily as in a breakthrough, like the deep learning breakthroughs of, we can now do speech recognition with so much more accuracy because we have giant neural nets, but more like HCI and human-computer interaction. I think it will pervade many different facets of computer science. So such as AI and such as big data, such as systems, because I think that people are now more and more realizing that there's only so much you can go without involving people at a very deep level. And so, machine learning is a great example, right? So there's this field opening up of interpretable machine learning and human in the loop machine learning. The field of databases, a lot of modern researchers in database think about interactive systems, graphical systems for querying data, and for presenting data to users, for building custom data visualization dashboards. I think HCI, human-computer interaction, is going to be everywhere in computer science and in other fields. One, I'm obviously biased because I'm in that field, but for the really simple reason that all we do is we are humans interacting with computers, right? It seems really obvious, but I think there's only so much you can push computers by themselves without considering the human interaction as a first class citizen. And already, top computer science departments all now have a growing presence in HCI, and where the top schools go, other schools are going to follow. So I think I'm very optimistic on that. I wouldn't call it a breakthrough because it's not like, oh my God, HCI will cause us to, have some magical human superintelligence breakthrough, but more like a permeation into everything. How do you deal with the situation when none of your thesis committee members are experts in one of the core fields of your dissertation? so this is when none of your thesis committee members are experts in the core field. I mean, I would have a very frank conversation with a very candid conversation with the person who is your advisor or who's the person leading your committee, because they are ultimately the person who is controlling whether you will graduate or not, right? So, somebody has the main kind of clout in terms of determining whether you have done enough for a PhD to graduate and to move on. I would talk to that person and say, okay, look, you're not an expert in this area, but what should I do in order to make this project progress so I can graduate? Should I try to shift it into an area that you're more an expert in? Should I try to submit maybe some smaller papers so that if they're easier to get accepted? Should we try to see if I can just write up a dissertation without having anything published yet? And what should we do? I think you should talk to the primary person, because usually on a committee, there's one primary person who's your advisor and everyone else is just kind of there to kind of supplement and go along. I mean, they're usually, once your advisor approves and says things are good, usually the other people say, okay, fine, that seems okay, unless some really, really bad situation occurs. So I would look into that. I mean, the hard thing though is if no one's an expert in your field, the problem is that you're going to have a harder time publishing papers in top venues, which makes it harder for you to get research jobs in the future. So that's just a hard situation. But I think in terms of if your immediate goal is to like get your dissertation done and graduate, which I think should be goal number one before thinking about anything else, is to talk to your primary advisor. So now that you are on the other side of the table, how do you, as in UC San Diego, hire CS professors? What is the process behind the scenes? First of all, I am not a CS professor. Well, I am a CS professor because I'm a cognitive science professor. So that's CS. Our CS department or computer science department is called CSE, or computer science and engineering. So I am in the cognitive science department. I am not actually in the computer science and engineering department. I have an affiliation, but I don't have I'm not paid by them. That's a really big question. I wrote an article kind of about that. Again, it's one of these really general questions that's hard to answer off the bat. I think I have, if you look at my website and you look up faculty, I think there's a section, I'm just going to pull up my website. On the side, on the right side, there's a section about categories, and there's a section called faculty job applications. There's a section, and there's a bunch of articles. And I think that, distills all of my knowledge on that. I think as far as you should be concerned as an applicant, you shouldn't really be concerned with what happens behind the scenes because you can't control it all. So that's my biggest piece of advice. You should treat what happens behind the scenes as completely random and chance. And you should just try to maximize your position given you're on the outside. And also, distribute your efforts towards many schools and such, because there's no way to tell what's going to happen in one particular school. It could be really idiosyncratic because it could be that. I'll give you kind of an example. This is a fake example, but I'll make one up. Is that sometimes the job ad that's posted publicly says one thing, says we want to hire in field X, and it's because the school got money or the department got money or some kind of political influence to put out a job ad officially for field X. But really the faculty inside the department want to hire in field Y. That's different, but they need to put out the job ad in field X. Then they try to look for candidates that are kind of like X, kind of like Y, and maybe they interview some X people and then some Y people, but the people in charge really want to hire the Y people, right? Again, I'm making this up. It's completely hypothetical, but you can't control that as an applicant, so you shouldn't even try to think about all the stuff that happens behind the scenes. What's your opinions on the differences of industry and academia? What are the advantages to be? What are the advantages for PhDs to be in industry compared to other developers? So I assume developers are software developers. There's two questions in one. One is, given you have a PhD, I assume in a technical field, what is the difference between doing industry and academic? And the second question is, if you are in industry, what is the difference between having a PhD versus not having a PhD? Both are really good questions. I've written kind of about the first one. There's actually directly an article about the first one. Again, I keep on sending people the articles, but for ones with longer answers, I would send you to one of the articles. And if you look up like academia versus industry, there's an exact article about this. The advantage of PhD in industry compared to other developers, I think that if you're in a position where your job is a software developer, there may not be a giant difference because people don't really care about the degree that much. I mean, having the PhD perhaps opens you up to jobs that are more R&D or in kind of a research and development role where your entire team is PhDs. So I would suggest for the second question is if you really want to somehow use that degree, I would try to go into industry in a position where your whole team or the majority of your team are all PhDs. So in a research lab or in an R&D wing or in some kind of prototyping lab inside your company where you're working with other people with PhDs. And that's both, perhaps beneficial because it uses your degree and also because socially you're around people who share your similar background and interest in research and such. Rather than, say, general software developers right out of college. Do you see any substantial change in higher education models due to online courses like Coursera within 10 years? That's a great question. So when MOOCs, when these online courses such as Coursera, edX, Udacity came out 5 years ago around, they made this big hype about how this is going to destroy universities. And within 10 years or 20 years, all universities are going to shut down and go bankrupt. And then we're all going to go to Coursera or Udacity or edX, and everyone's going to get their education from there. And that's going to be a new business model. I think that Silicon Valley hyped that up a lot in the press because they needed to raise, Coursera and Udacity are both for-profit companies that are venture capital backed, right? edX is a nonprofit, but they still have donors. And full disclosure, I worked at edX for a summer. I've not worked at the other two, but edX is nonprofit, but they still need to get donors and money coming in, right, to run an operation. Same with Khan Academy. Khan Academy is nonprofit, but they have like hundreds of employees they need to pay. So they need to get enough donations and philanthropy and grants. And so I think that it is in all of their interest to say that we're going to totally change higher education and things are going to be completely different in 10 years. I think that institutions of higher education move incredibly slowly for better and for worse, right? So, since obviously I am in one, it's better for me that they move slowly because then, people keep their jobs for longer. But in a more practical view, I think it's good that academia moves at a much slower pace than industry because there does need to be some kind of constancy across time, right? Like, the typical thing in the tech industry, at least, is that things change every like 3 to 5 years, right? People are changing jobs, people are changing technologies, entire companies go up and down within that time. New technology comes up, gets disrupted in the market by another one, and then gets, think about the social networks and apps and all those things. I think that it is important to have academic institutions last on the order of decades or even centuries because that's where fundamental research and education and stuff are being done. And I think that sort of stuff it's comes into danger when you're changing it every year or two. So kind of the long answer to your question is that I don't think within 10 years, at least the major research institutions will change much. So anything within again, I don't like rankings, but in the United States, I guess, anything within the top 100 schools, right, in the United States. And these are usually large research universities or what they call R1 universities. I don't think that's going to change a ton. I do think that it will change things in terms of smaller schools, these smaller for-profit schools, these really tiny schools with small budgets. I think that online education models are going to disrupt those a lot more because that coupled with student debt crisis and the increasing cost of tuition and everything, that's going to, the schools that are in trouble are more the smaller ones on the long tail. The small for-profit universities, the small liberal arts colleges, they are more in danger than the large, research institutions. And it's because large research-based institutions are not just quote unquote schools, right? They're entire institutions. Many of the major schools I've been to, they hire, 50,000 people, 50,000 people. They are the size of big companies. And, those things just don't crumble that fast, right? And also they are sustained by a research pipeline of government funding and industry funding as well. So it's not just about the classroom learning part. I think that interesting thing about colleges would be that their teaching might change, right? They might move to a more blended online learning model. But I think schools, as they will about 10 years, I think will still pretty much, the major big schools will be pretty much the same. That's just my prediction. I'm not in the business of predicting the future. Where do all the older people in tech go? That's a great question. I did this paper recently about older adults learning computer programming that got a bit of attention in the press and stuff. So where do all the older people in tech go? That's a great question. I'm not the best person to answer that question, but You can read things on like Hacker News and on other forums. You know, high tech stuff, especially in software, is kind of notoriously known as a very youth-centered business. The average age of a lot of these tech companies are 30 or maybe below for a startup, for a smaller company, maybe in their 30s. Yeah, that begs the question, where do older people who are older go? One answer is that they go into more managerial track. So if you look at companies, mid-sized to big companies, the people who are managers are usually a little bit older, right? They're 35, 40, 45, and then higher up middle management layers, higher management layers. So that's one answer to that, is that they often go into management, because if you think about a big company, if it's a pyramid, there are way more layers of management, middle management, than there are engineers or technicians, because there are many layers of management in the middle. So management is one, or some people stay in tech doing technical work their whole careers. They specialize a lot, or they switch jobs, or they go independent, right? If they're having trouble in the job market. Doing technical work, they do consulting, they do part-time work. Some of them, when they're older, they go into teaching. They go into teaching part-time at the college level, right? Or in community colleges and stuff, or just kind of freelance consulting and stuff. That's a good question. Can getting a postdoc at a top 10 school in your field open up the door to get into a competitive school for, I assume, faculty jobs? I think so. I mean, that's one way to kind of, we talked about rankings earlier, that it is very hard to get a faculty job at a place if your PhD institution may not be as well ranked, just because, due to the realities of the job market. So one way to help that is to get a postdoc, to get another position after your PhD at a top school, a top 10 school at the questioner asked. It does definitely open the door. It's not a guarantee, obviously, but it will, make your CV or resume look better. But, once you have that postdoc, I would suggest to you to really focus hard on publishing first author papers. Treat that as your second chance at a PhD, right? It's like, treat that postdoc as a second abbreviated PhD, where you can get your name on several first author papers with your postdoc lab at a top school and apply for faculty positions using that new resume. So I think a postdoc at a top 10 school is a great idea, but it automatically doesn't guarantee you anything, right? You still have to put in that work. Any advice on porting an existing project to another language like C to Python? Obviously, there's no easier solution than writing bindings. Any interesting solutions? Yeah, I mean, C to Python's pretty hard. Yeah, I mean, rewrites are usually the way. Another thing people do is that they port only parts of it. So some languages, if there's a really big part of your code base, you might change one little bit at a time and then just kind of change as you go. It really depends, because a lot of these languages like Python or Ruby, they interface really well with, say, C. I mean, C interfaces well with everything. So if you have a giant C project, you might be able to rip certain parts and port it to another language and then just still interface with the rest of your C parts. And you don't have to port the whole thing at once. But I would really question why you want to port something big in the first place, because there might be a better solution. In general, like rewriting all your code is probably not a good idea unless you have a really compelling reason. Unless someone's like, we're going to give you $10 million to rewrite your code, it may not be a good idea. Do you have any tips for getting into research as an undergraduate student? Yes, I think I have an article about this kind of. If you look up, there's like an undergrad, I'm sorry to keep sending people to articles, but I write a lot of these articles because people ask me questions a lot on these topics. So undergraduate research as an undergrad, I think the biggest tip that I have that's not probably written is take a class that's an upper division class with a professor and do well in the class, and then talk to them. I think that's a very surefire, because especially if you're in a large university, professors have all sorts of students coming up to them and asking about research opportunities. And one, if you don't know any better, you don't know these students because there's so many of them. How do you pick? One surefire way is, I took your class last semester. Hopefully it's an advanced class and it's not like a intro class where there are 500 students, you don't know anyone. I mean, that's fine also. But if it's a more advanced class, like I took your upper division class on X, and obviously a lot of those upper division classes, they involve projects, they involve discussion. So if you do well in the projects and discussion, you talk to the professor after class and office hours, and they get to know you, and they're like, oh, this person actually did a really cool project for my class. And then you ask about research opportunities. That's just a very organic connection to get in. I mean, it takes work, right? It's not just like you're coming up to someone blindly, but I think it could be satisfying because, if you're in their class and you like what their class teaches, supposedly you might want to keep working in there. So I think that the taking an advanced class and then doing well in it and then talking to them afterwards is I think that's a great strategy. Have you tried to read The Art of Computer Programming by Donald Knuth? If so, what's your experience? I have not tried to read The Art of Computer Programming. So for those who don't know, The Art of Computer Programming is this classic set of books about algorithms and computer programming by Donald Knuth, who's a Turing Award winner and a kind of a classic, person who founded many things in classic algorithms and computer science. And I've never read that book. One, because I don't do a lot of theory stuff. As I said, I'm kind of the opposite of doing theory stuff. I'm very much on the applied end. And also, like, I never had it for a class. I think it'd be cool if people have to read it for a class. I just never had to read it for any reason. The most theoretical stuff I've read was the CLRS book, what is it? Corman, Lyserson, Revest, and Stein, Introduction to Algorithms, I think that's what it's called. I have it down here. Hold on one second. I'm going to knock over my bookshelf. Hold on. I don't actually have many books. If you notice, I don't have a bookshelf. But this book is on my floor. Ooh. So this is a classic algorithms textbook. I mean, I had to read it for a class, but it's, it's a great and timeless book and, on algorithms. So that's the closest I've gotten to that. But mostly I use these textbooks to hold up my monitor. Do you see data science becoming a mainstream scientific field in academia? If so, how would it relate more to traditional fields such as, statistics and computer science? That's a great question. Data science is something that's been much of a buzzword in the last 5 years in industry and also starting in academia. Many schools are getting large amounts of money for starting data science programs in education research. So UC San Diego recently got $75 million, I think, from one of our alumni who was an early engineer at Facebook. So he was I think it was a computer science and engineering alumni. This is also why it's important as a university to treat your students and alumni well, because it's not just because you want to be a good person. It's because someday one of these alumni are going to be super rich because they joined a company and they will want to donate to your school if they like you. So this guy is donating $75 million to start Data Science Institute at UC San Diego. Other notable schools, University of Washington, Berkeley, and NYU got a bunch of money, like $38 million from several big philanthropy foundations to start data science. Other schools, I was at the University of Rochester before this, they got, tens of millions from one of the local businessmen to start Data Science Institute. They built a new building. So there's a lot of hype around data science. And there are not, and Yale is recently just starting a data science department, I think, or they renamed statistics data science, and there's a lot of political turmoil about all that. I definitely think that it's going to become a major because of where the trends are going. Because, if there is a big demand for data scientists as a job title, which there is, and hopefully there will continue to be, if there's a demand in industry, people in the universities are going to demand a major. Right now, data science is a minor in a lot of schools, or a specialization, or a interdisciplinary program, but eventually it'll turn its way into a major. I'm pretty sure. I mean, I have no insider knowledge. I am not involved in data science initiatives in any official capacity. I have no, actual knowledge of this, but just to see where trends are going, it's going to become a major. And then the question is, how would it relate to other majors like statistics, computer science, applied math, economics, those things? I think that's going to depend on the school. I feel like different schools, the data science major is going to crop out of different things politically and organizationally and how they organize themselves. Or is this going to be a statistics heavy department? Is this a computers heavy department? Is this a theoretical math heavy department? Is this a management science business school type department for data science? I think it's going to be really fascinating. And just like computer science departments sprung out of math departments or physics departments or engineering departments 40 years ago, 40 years ago, there was no computer science department. It was just some weird thing you played with when you're majoring in math or physics. And then slowly it started becoming a department. But I think data science is following the same path. So it's a cool time to follow that. What productivity tools do you use? To-do list, notes, or do you mostly use whiteboards like the ones here in simple text files? Yeah, so if you notice behind me, this is my home office, this is my house, my home office. I have 2 standing whiteboards. They're standing because I don't want to like pound stuff into the wall, because I don't like, nailing stuff on the wall and they're heavy. So I just stand them, and they're 4 foot by 6 foot, and they're just standing. They're great. They're a cool set piece also. I love whiteboards for just throwing up ideas and persistent things. I also have a bunch of whiteboards in my office as well. I think they're mounted on the wall in the office. But really, I use very little productivity software. I use none. I literally have one to-do list. I have a document on my computer that's called a to-do list. It's just a text file I edit in my text editor. I use Vim. I just edit in my text editor and just write stuff. I just write stuff into it. And I have done this since I have used this one to-do list method since I was in high school. And in high school, I just had a text file. Back then, it was on Windows 95, right? Windows 98, Windows 95. It was Notepad, just the Notepad app. I just had a text file on my desktop called Notes or To-Dos, and I just double click on it whenever I get on my computer and I just start writing stuff. And that's it. I did that in high school. I did it in college. In graduate school now, one to-do list. Of course, I write my notes in other places too, right? Each project has some notes. I have some Google Docs. I collaborate with people. But like in terms of like, what am I supposed to do today? I just have notes. I also have a Google Calendar. So Google Calendar is useful because a lot of my to-dos are meetings. So like if I'm meeting with students or I'm teaching or I'm, giving a talk at some time or needing to attend someone's talk, those obviously go on the calendar. So anything that's time specific goes on the calendar. Anything that's not time specific, I just put on to-do list, and I don't use anything else. And that has worked for me because it just keeps things really simple. It keeps things simple and also prevents me from trying to do too much, right? Like if I only have one to-do list, I can't. I feel like this is just my own anecdote, but I feel like I've been able to focus really well because I don't have too many things on my to-do list. Because like I don't have all these different apps and sticky notes and stuff everywhere. I just can't take on that many projects at once. So it forces me to simplify what I work on. That's just my rationalization. What advice would you give to someone who has just started reading research papers? How is it different from reading a technical textbook? I'm trying to read machine learning papers. That's a great question. I don't have an article exactly about that. I have an article about, it's called directed paper reading. I think it's called directed, no, it's called Okay, I have oh, it's too bad. I wish I could display text on the video. There's probably a way, but I don't know how. But anyways, because a lot of times I want to send people links, and chat doesn't persist. I would love it for it to persist, but it'd be like, great, put a link right here. Click on it. Anyways, I have an article called Opportunistic Paper Reading, which is how to read papers if you really want to do research in a field, to be really precise about it. That doesn't sound like your question. Your question is more about just getting started, getting into a field. I think the best way is to do it with someone else's supervision. Frankly, I think it's very daunting to just say, okay, I'm going to learn machine learning. Here's some papers in the latest machine learning conferences or journals. Let me start reading it and just trying to get something out of it. I think it's really daunting because there are just so many papers. Like, where do you start, right? And also, where do you position these papers relative to each other, and how do you weigh them? Is this just some wacky thing that someone wrote that doesn't really work and is badly written, or is this like the top of the line research in a field? One way to think about this is looking at the top conferences or journals in your field and looking at the best paper awards or like really notable papers. I would start with those because that those at least were well written because they're the top papers in the top conferences or journals. I would say like if you just were to pick random papers to read, I think it's kind of dangerous because it's kind of like picking like a random thing to read on the internet, right? Like it could be good, but most likely it may not be great. And it may kind of throw you off. So I would say consult some people who are more experienced in the topic and just ask them what papers they recommend you read. So it's like, I'm getting into machine learning. I want to do computer vision. What is the 3 most recent awesome computer vision papers I should read that is actually pretty accessible to beginners. Should computer science undergrads interested in going to grad school focus on depth or breadth research-wise? Focusing on one subfield definitely increases the probability of publication, but at the cost of not exploring other topics. That's a great question. I mean, that's a question of depth versus breadth, which applies to everything. I think, what I did was that I gave myself a 5th year. So I did a 4-year undergrad plus a 1-year master's thing. So I applied to grad schools out of my 5th year, which actually helped a lot because I had an extra year to do research. So I worked in, I think, 2 research labs very casually, very early on to explore different areas. And then I went to the last one in undergrad where I ended up doing my master's work and applying to grad school and publishing some papers, although I didn't publish papers until after I got into grad school. I had about 2 years in that last place. So I think that the way to explore is the time to explore is as early as possible. But if you are getting a little later, since, it's funny because if you want to apply right out of college, your senior year, you don't have much time, right? I had the luxury of 1 extra year, but if you're applying, you need to basically have all your work done by the beginning of your 4th year of your senior year, because you're applying to grad schools at the beginning of your 4th year. That gives you your 3rd year, your junior year, and maybe part of your sophomore, your 2nd year, and maybe some summers. So at most, you get 1 year or a year and a half in a lab. And that is not much time. I think that, maybe if I really had to answer that question fast is just to focus on one area and try to get a publication out, or at least be able to get involved in a project deep enough. So I would say, ideally you would start really early and you start in your 1st or 2nd year and explore around a lab or 2, hang out and stuff and see what's right for you and then just pick one. But I guess my advice is, unless you start really early and explore, there's not much time to explore. So I would just say go with one thing so you can have some substance, like a year and a year and a half in a lab, and then use that to apply to grad schools. And remember, like what you do in your undergrad does not have to have any bearing on what you end up doing later in your career. You just want to get enough experience so you look strong as an applicant. And then later on, you can switch areas or stuff. But I would go for depth. Okay, what is your favorite? Who is your favorite computer scientist or scientist in general? In case you don't have one, it's an interesting question. I don't know. I guess I wouldn't say I have one favorite, right? I think that because different people are good at different things, and I just finished reading this book on Xerox PARC, which is called Dealers of Lightning. And if you look up Dealers of Lightning on Amazon, Dealers of Lightning Xerox PARC. Xerox is the company, Xerox PARC, PARC. Is this fascinating book on the tenure period between 1970 and 1980, where Xerox had this research lab that invented many of the things in personal computing today, like networked computers via Ethernet, graphical user interfaces, email, laser printing, object-oriented programming with Smalltalk. So many amazing inventions came out of that lab in 10 years. So I would say, if I had to say a favorite, I would say like that period was awesome. I don't necessarily, idolize any of the individual people because a lot of them had very strong and abrasive personalities, and it was a very kind of cutthroat world. But just that period of being in Xerox PARC from 1970 to 1980 was just this like golden era for computer science, and so much awesome computer science foundational work came out of that. So I would say that Xerox PARC era is, at least on my mind right now because I finished reading that book. So Dealers of Lightning, I really recommend that book. How can non-tech people improve communication with CS academic? That's a great question. It's a hard question. It implies both ways, right? How can people not in tech improve communication with computer scientists in academia? And the other way around, how can academics communicate better with the public? It's a hard question. I try to do my part by blogging, making videos, those things. One of my colleagues, Jean Yang, Jean, her last name is Yang, Yang. She's a professor at Carnegie Mellon. She does a really good job with blogging and doing science writing and outreach and stuff. She's a lot more famous than I am in this. There are other people who do science communication who are great at communicating with the public. I think computer science is not as good at some of the other fields, maybe because we're younger. I mean, we don't have someone like Neil deGrasse Tyson, who is an astrophysicist, who is a very popular science communicator. We don't have anyone like Carl Sagan, who is, kind of that person for physics in the former day, or Richard Feynman, or even folks like Stephen Hawking, who is, more of a public figure in that way. Those are more in the kind of traditional physical sciences. But I would love for computer science and human computer interaction and computing in general to get to the point where we have these awesome public figures who are communicating with the public. I mean, there are people who are like well known within the field, but like I think there's a lot of work there. But I think it's getting easier with online media, social media, blogging, and stuff. I think that connection is coming together more. I mean, one great way is thinking about Twitter, right? All these academics who are on Twitter talking about things and commuting with people who are in industry and other fields. What is your advice for non-CS student, master student, OR? I assume that's operations research, wanting to learn parallel programming of algorithms. Should I dive into it or take some coding courses first? I would say just have an application area you need. First of all, why do you need to do parallel programming? First of all, like, you may not even need to do anything in parallel. You may be able to just run all your stuff on a single thread. If you can do that, go ahead. I would say if you're a student in whatever field, think about what problem you need to solve and only learn what you need to solve that problem. Like, don't just think, oh, I need to do parallel, or I need to do big data, I need to do cloud computing or a cluster because I need to do it. Only if you really need to. I mean, a lot of people doing research in computation can just do it on their laptops nowadays. And I think that if you need to do it, then you can start thinking about the simplest thing you need to learn. I wouldn't go and just try to take a bunch of courses or everything. So my advice there is, do what you actually need to do and not think, oh, I need to learn parallel programming because I need to. What is the best way to quote unquote close the gap if you are a self-taught programmer without a CS degree? Is it worth going back to school if you're already in industry? Yeah, so this close the gap thing is a video I just made like 2 days or 3 days ago about how it just takes a long time. I mean, it takes 5-10 years to gain that expertise in an area to the point where you become really proficient. So this question is about if you're self-taught without a CS degree, is it worth going back to school full time, or if you're in industry? I think it's you want to know. I think you want to think about what you want to get out of it, right? So I think that it's often very hard to pause what you're doing and go back to school for 2 years, even, or 4 years. I mean, that's a long time out of your career. Recently, some of these coding boot camps have been gaining a lot of popularity because they are for people who are perhaps self-taught programmers or wanting to get into programming and only have 3 months out of their schedule. They can't spend 2 years in school. So maybe looking into some of those, but again, those vary a lot in quality. There are some great ones. There are some that are not as good. If you look into a really good one that can teach you fundamentals and the useful skills you want, that may be a good use of your time, rather than going all out and just saying, I'm going to quit my job and being in school. The other way is to do night classes and extension schools. That's very common that companies, especially a big company, will pay for you to, will pay part of your tuition to attend, one class a term. And you might get a master's degree or a certificate in data science or software engineering. Maybe it'll take you 3 years or 5 years, but it's okay because you're just working your job and you're doing night classes one day a week or something. That might be the best compromise, I think, because you can at least get some of that classroom experience without quitting your job. So I would recommend that. It takes longer, but I think that getting out of a job and then going back to school completely is a very drastic move, and it's expensive. So, and I don't know if you'll get enough out of it for such a drastic move.